Sorry for the interruption. Video was got off, so I don't know how much it was. I taught you. So okay, let me re-discuss the things. So we have got euro as a form of this two asymptotic behavior. So we will get got this equation, okay, as a function of 0. Fine. Now we will replace the 0 term in the main equation. That is that radial equation in the form of b2u by d rho square. So for that we have to calculate these two derivatives, and we have done these two derivatives, and we have to replace this thing, and after replacing we got this equation. So fine, now we will solve this equation, and for this time we will apply the already power series method for this method. Fine. So for power series method, you know that we have to consider v rho in some form of summation, you know it, no? It is Cj and you can say right, and it is done in some J. So it is 0 to infinity when you find it. Fine. So now you know that for power series method, we will just follow the power series method. So just we make derivative z equals to 0 to suppose J Cj is a constant. To j minus 1, and if you replace the thing, because for j equal to 0 there is no meaning, so first term have to be you have to replace, otherwise j equals to j plus 1, right? So summation j equals to 0, so j plus 1 j plus 1, you can understand. Then you have to replace the thing j equals to j plus 1. So now the equation is valid. Fine. So again you have to find out the second derivative, d2p by d rho, okay, d rho, so summation j equals to 0 to infinity j into j plus 1, 3j plus 1 or j minus 1. Fine. So if you replace these two and put these two values on the main equation, so you will get now putting values, you will get j into j plus 1 cj plus 1, right, rho j plus 2 l plus 1 summation. Just I have put t in the main equation, both down in the main equation. Oh, sorry, the second term, right? Eliminate first term cj plus 1, okay, rho j, it is a meaningless of minus 1, okay, so for that you have to replace this thing. Okay, fine. Plus 2 a plus 1 into j plus 1 cj plus 1 rho j, okay, minus 2 j that term cj rho j plus rho 0 minus 2 into a plus 1 summation j equals to 0 cj rho j equals to 0. So if you look at the equation, just add this those terms, okay. So fine, we have put the term in the equation. Fine, this is fine. Now our always in the power series method, always we always try to find the recursion relation. So in this time also we will find the same thing. So if coefficient of the same power will be 0, okay. So let us write rho j, suppose rho j, so all are the rho j, so simply j plus 1 c j plus 1, okay. Just write the terms. So equal to the coefficient coefficients as 0. Zero. Okay. From this equation, we will get the differential relation as Cj plus 1 equals to 2j plus L minus 1, sorry, plus 1 minus rho 0, right, by j plus 1 j plus 2L plus 2 Cj. So if you know the C0, then you can calculate all the terms, C1, C2, C4, C4, right, in terms of C0. So, and C0 will get by the normalization factor. Okay. So now we'll look at the thing at j equals to very big value, and if j is very large, if suppose j is very large, so j is very large, so we will get equation like okay. All other terms will be neglected. Very fine. Jj, and this is 2 by j plus 1 c, right? Fine. So this is very good. Now if we think about the thing, putting all the things c1, c2, c4, c3 like that, so we will get the equation like this solution like 2j factorial. Okay, fine. If this is so, p rho will be, just put the values of cj there. So p rho will be, you can see, just we put that we have taken at the initial position of the power series method, where we have considered p rho as cj into rho to the power j. Just replace that part, you will get like that. So this is eventually we got, sorry, e, oh shit, e to the power 2 rho, right? Fine. So if you replace the v rho at the term at the equation of, or at the equation of u rho, where you have written u rho in terms of v rho, just you will get c0. Just replacing all the terms. This is work of replacement, nothing else. Fine. So again look at the term, it is again e rho, and we don't want this thing, because it is if we put rho tending to infinity, then again this equation will blow up. So as it is a conventional thing that if this is so, then what we have to do, we have to truncate the series. So truncate the series, so that if you truncate the series, so there will be j max term, right? J max plus 1. After that the term will be c, this coefficient will be 0. Fine. If it is so, if you look at the recursion relation, that recursion relation put there, and you will get like suppose 2 j max plus L plus 1 minus rho 0 equals to 0. Right, fine. So if you now think about n equals to suppose plus L plus 1, this term. Now the only thing you will get that rho 0 equals to 2n, right? Just replace this one and you will get this term. Now if you put this term in the recursion relation, so you will get the recursion relation as recursion relation c j plus 1. Okay, so 2, if you take a bracket, okay, j plus L plus 1, okay, minus 2n, n, we have taken the bracket, j plus 1 j plus 2L minus plus 2 cj, and this looks like some Laguerre equation. This is a recursion relation of Laguerre, associated Laguerre method, Laguerre polynomial. So for that we will just apply the solution of that Laguerre method. So now you will get v rho as in the Laguerre definition 2L plus 1 n minus L minus 1 is is a very known method actually in applied mathematics. So this is the equation, and these they are defined as suppose p and suppose q p x. This is defined as like that, ddx p in q x, like that. Okay, this is associated Liber polynomial, and the Liber polynomial is defined as e to the power x dx q. Okay, e minus x to the power q. So if now you got the solution of 0, you consequently you know so solution of the actual radial function. Okay, now the solution will be, now you understand. If that is so, you got the full solution, because previously we have done the solution for angular part, and this time we have done for the radial part. So fine, so final solution, you can understand r, theta and phi in terms of r n l, that the thing we have done just now, and it is we have done previously. So final solution is, this is the final solution. Now question is applying the Liber polynomial. I'm not writing the Liber polynomials here. You can see it in any standard book. In any standard book you will get the thing. So just look at the Liber polynomials, and you will find the radial solution of the hydrogen like atom. And please try to plot them in your what is called Python. Try to plot them in Python. You will get very interesting curves and very interesting figures. Okay, please try to plot them. Okay, fine. So now this is a solution. This is okay. Now just let me a little bit discuss about the energy. So we have got rho 0 equals to 2n, right? So now in the previous equation, where we have defined k in terms of E, from the equation you will get energy equals to minus h car k square by 2m, and if you put the value k there in terms of rho 0, you will get right m e to the power 4 8 minus, so there is minus pi square e square h cut square, okay, rho 0 square. Now if you put the value of rho 0, you can understand here m square, so something like energy will look en minus m by 2 cut square e square by 4 pi epsilon 0 square 1 by m square. This is very interesting. Already you have learned this thing, right? U1 by m square. So this is the ground state energy, U1. So for suppose n equals to 1, 2, 3, like this. Very interesting, the ground state energy. And other thing you have to see that for k term, previously we got m square by 4 pi epsilon 0 8 square by 1 by n. And this is defined as an. This a is actually called the Bohr radius. So this is the Bohr formula. You have known this thing in your class 2 level formula, and this is Bohr radius. So okay, that's okay. Please look at the Liber polynomial and the form of the Liber polynomial, and replace in the radial function, radial part, and please try to plot the radial solution. So you will find very interesting thing there. Please do it at home.